Yeah. This Zoom session is brought to you by the fractal round hex quilt E. I thought that one was particularly pretty. All right, for today, what are we up to? Factoring. Here we go. Differences of squares, differences of cubes, sums of cubes. Okay, difference of squares. X squared minus y squared equals difference times sum. X minus y times x plus y. They can prove that by multiplying it out. X times x minus yx plus xy minus y squared. The minus yx and the plus xy cancel out. So you get this. We'll be using this a lot more when we start solving quadratics in general. I call this a 99 rule because if you let x equal to 10 and y equal to 1, then the left side is 10 squared minus 1 squared. It's 100 minus 1, which is 99. And the right side is not 10 minus 1 times 10 plus 1. That's 9 times 11, also 99. So that's my name for this. Related to this rule is the difference of cubes. Obviously a closely related concept. And this equals a difference, x minus y times this somewhat more complicated thing, x squared plus xy plus y squared. Square plus product plus square. And I call this the 999 rule. Namely, if you have x be 10 and y be 1, the left side is 1,000 minus 1, or 999. The right side is 9 times 111, also 999. All right, here's a somewhat different one, a little different from this one. Sum of cubes. Well, the trick here is just to replace every odd power of y to flip its sign. So the idea is you start with this and put a negative y in for y. So third powers flip over x cubed plus y cubed. The minus y flips to a plus y. The plus xy flips to a minus xy, but all the y squared stays what it is. So, okay, difference times square plus product plus square, sum times square minus product plus square. Watch out about mixing these up. I've often seen people try sum times this or difference times that. Try not to do that. So this does require a little bit of memorizing. This is very easy to remember. Okay, so we use these and plenty of examples. Here we go. All right, some simple ones. X squared minus 16. Well, that's x squared minus 4 squared. So x minus 4 times x plus 4. Here's a little more complicated, but very similar in certain ways. 9y squared minus 64. This 9y squared is the square of 3y. This 64 is the square of 8. So you get 3y minus 8 times 3y plus 8. Here, another similar one where you figure out these are squares. 100m squared minus 1. 100m squared is the square of 10m. 1 is 1 squared. And the difference then is 10m minus 1 times 10m plus 1. Difference times sum. Here we wind up using the rule a couple times. They're being cubed. 16a to the fourth minus 81b to the fourth. Now 16a to the fourth is a square of 4a squared. 81b to the fourth is square of 9b squared. So difference of squares will be difference times sum. 9a squared, 4a squared minus 9b squared, 4a squared plus 9b squared. Now these also are squares. 4a squared is the square of 2a, 9b squared is the square of 3b. Difference of these squares is 2a minus 3b times 2a plus 3b, and then times this 4a squared plus 9b squared. This brings into focus an interesting fact. We don't have a factoring rule we have a factoring rule for a difference of squares, but we don't have a similar rule for the sum of squares. But we will later on when we get to what are called complex numbers. We have to have a square root of minus 1 to make it work. All right. Not yet, but later. Here, this looks troublesome because it doesn't look like a square, 2x squared. However, there's a 2 and the 288 have a common factor of 2, which we pull out. And when we do that, we're left with 2 times x squared minus 144. And these are squares. 2 times the square of x minus the square of 12. And so this is a difference of squares. So you get 2 times x minus 12 times x plus 12. Now, in dealing with a problem like this, please remember to bring this factor along. I've seen people forget about it halfway along and wrong answer. Now here, now we have a sum of cubes. A cubed plus 125, well, 125 is 5 cubed. Square, cube, plus cube. Okay, that's a sum times square minus product plus square. A plus 5 times square, a squared minus product, 5a plus square, 5 squared. There's always a step where we have to turn this to kind of neaten it out. So you get a plus 5 times a squared minus 5a plus 25. So with the sum, you have to have this plus minus plus for the second factor. Similar deal, 8r squared plus r cubed plus s cubed. 8r cubed is the cube of 2r plus s cubed. So okay, sum 2r plus s here, and then square minus product plus square. And again, you have to work this out. So it's 2r plus s times this first square of 2r is 4r squared. This term here is minus 2rs. This term here is s squared. All right. Now this is another messy one. 64t to the 6th minus 27v to the 3rd. Ugh. Well, these are both cubes. 64t to the 6th is the cube of 4t squared. 27v cubed is the cube of 3v. This is a difference of cubes. And the formula there is difference times square plus product plus square. So difference 4t squared minus 3v. Square of 4t squared plus 4t squared times 3v times square of 3v. And again, as usual, we have to work this out. And so you get 4t squared minus 3v times 16t to the 4th plus 12t squared v plus 9v squared. Here they're being cute because it's x to the 12th minus y to the 6th. And actually, it turns out there's two ways to go about this, because a 12th power and a 6th power, they're both squares and they're both cubes. And if you go the wrong way, then you might wind up getting kind of stuck. But so it turns out in this kind of thing, which is basically a difference of 6th powers, you think of it as a difference of squares of, in this case, x to the 6th and this y cubed. Difference of squares is difference times sum. X to the 6th minus y cubed, x to the 6th plus y cubed. The 6th power of x is a cube of x squared, here and here. So here we have a difference of cubes, and here we have a sum of cubes. And that we can work out. This difference of cubes is difference times square plus product plus square. This sum of cubes is sum times square minus product plus square. And as ever, we have to do a little bit of neatening out of these three-term factors. And so in the end, x squared minus y times x to the 4th plus x squared y plus y cubed. Oh, is that a y squared? That's a y squared. I have to
Hmm?
I am so sorry. I am so sorry. For some reason, every so often, my oh, hush bug. Every so often, my my cable modem cuts out. I think it overheats from time to time. And I thought replacing it would fix the problem, but okay, whatever. Let's hope it continues. All right, that's number 4. And so, Hushbug. Oh, that's no good. So let's end this. Oh, Hushbug, come on. Stop recording.